How do you handle errors and exceptions in Python? Imagine writing a program that crashes just because of one tiny mistake. That can be frustrating, right? Well, Python has a way to prevent that from happening. It's called exception handling. When your program runs into a problem like trying to divide by 0 or opening a file that doesn't exist, Python throws an exception. If you don't catch it, the program stops. But if you handle it properly, your program can keep going or give a helpful message. The main tool for this is the try and except blocks. You put the code that might cause an error inside the try block. Then, you add one or more except blocks to catch specific errors. For example, if you're converting user input to a number, you can catch a value error if they type something wrong. This way, instead of crashing, your program can tell the user what went wrong and ask again. It's best to keep try blocks small and focused. Don't wrap your whole program in one big try block because it can hide bugs. Instead, only put the code that might fail inside the try. When catching exceptions, be specific. For example, catch file not found error if a file isn't there, or zero division error if you try to divide by 0. This helps you understand what went wrong and fix it faster. Adding clear error messages inside your except blocks makes debugging easier. Instead of a generic message, tell the user exactly what happened. You can also use an else block after try to run code only if no errors occur. For example, if your input is valid, you can proceed with calculations. The finally block is useful for cleanup tasks, like closing files or releasing resources, no matter if an error happened or not. Sometimes, you might want to raise your own exceptions. For example, if a function receives invalid data, you can raise a built-in exception like value error or create your own custom exception class. This helps you catch specific issues early. When you catch an exception but want to re-raise it later, use the syntax that keeps the full error details. This is called preserving the traceback. Avoid using bare except clauses because they catch all errors, even ones you didn't expect. This can make debugging hard. Instead, catch only the exceptions you know how to handle. Logging is also helpful. By recording exceptions with stack traces, you can analyze what went wrong later and fix bugs more efficiently. Let's look at a simple example. Suppose you ask a user to enter a number. You try to convert their input to an integer. If they enter something invalid, you catch the value error and ask again. If it works, you show the square of the number. This keeps your program running smoothly even if the user makes a mistake. Another example is opening a file. You try to read data from a file. If the file isn't there, you catch the file not found error and tell the user. If you divide by 0, you catch zero division error and handle it gracefully. You can also create your own exceptions. Say you want to prevent negative numbers. You define a custom exception called negative number error. When a negative number is detected, you raise this exception. Then, you catch it and inform the user that negative numbers aren't allowed. By following these practices, you make your Python code more reliable and easier to debug. Proper exception handling helps you catch bugs early, give clear feedback, and keep your program running smoothly. It's a key skill in Python debugging and writing resilient programs.